So starting with the second cranial nerve. So the second cranial nerve is the optic nerve. Mainly there are three components: visual acuity, visual field, the color vision, and the fundoscopic examination and pupillary reaction are also part of this. Pupillary reaction can also be tested as it has both the components to work with, like even with the third cranial nerve. But here it is taken in this slide while explaining this slide. So first coming to the visual acuity, for neurological purposes, the corrected visual acuity is tested with eyeglasses or contact lenses. Each eye is checked individually. Distant vision is checked by the means of Snellen's chart, and the near vision is tested by means of the Jaggers chart. So visual acuity is a reflection of integrity of entire visual system, including the refractile components. It is important to remember that the visual acuity evaluates only the macular vision, which is the central 5-degree, is there, right? So the central 5-degree of the visual field, that is tested in the visual acuity. So that is the difference between the visual field and the visual acuity, why we are doing this. So visual field, when we speak of, so visual field extends to approximately 60 degrees nasally, then also to the 107 degrees temporally. So that is the width or the range of visual field. And here there is only 5 degrees of that is the visual acuity. So in the Snellen's chart, this is used for testing the distant vision. The chart is placed 6 meters from the patient. The patient covers his one eye and is asked to read the smallest line he can see accurately. So both eyes are not tested at the same time. We have to ask the patient to cover his one eye at first time and then to read with the other eye. Then Jaggers chart, this is for near vision. Chart is placed 30 centimeter from the patient here. So we have to remember that distance, 6 meter in distant vision, for near vision 30 centimeter. Then coming to the visual field. So as I said, before testing for the visual field, we have to know what is the visual field of the humans first. So I'll repeat that part. Visual field extends to approximately 60 degrees nasally, that is towards the nose or inward. Then to 107 degrees temporally, that is away from the nose or outwards. So visual field is measured by the perimetry. What is this perimetry is? Patient and examiner sits or stands facing each other at 1 meter distance with eyes at the same level. Each eye is tested separately. To test the right eye of the patient, he covers his left eye with his left hand and look straight to the eyes of the examiner and not on any other object. It is straight into the eye of the examiner. Then ask the patient to look into the eye, not the object. The examiner hold an object or his finger in a plane midway between them, as you can see in the picture right below. So the patient is, the examiner is taking his finger firstly away from the patient and gradually taking to the middle part. Okay. So then bring the moving object from the periphery till the examiner is able to see it. If the patient has the normal vision, he also will see at the same time, at the same distance as the examiner sees it. If not, moving the object medially until the patient sees it. So the physiology is the patient should also see at the same visual field as the examiner sees. But if there is any pathology, he might not be able to have that wide range of visual field, but it can be constricted. Then we have to bring the finger until, unless and until the patient sees, till then, that point we have to bring our fingers. Then coming to the color vision, tested with the helps of the Ishihara's chart. So this visual field has all, I'll give you some examples where it can go wrong, because it involves the components starting right from the retina, then the nerve, then the chiasma tract till the cortex. From this, in this channel, anywhere the problem can lie and the visual field can get impaired. So just for example, if there is any pituitary tumor, then there can be bitemporal hemianopia. So that might be the condition. Then that is in both the fields, left and the right fields, half the thing is not visible. Okay. So half the temporal part is not visible. Then in any other thing is multiple sclerosis, for example. The lesion can be in the retrobulbar neuritis. So it can be central scotoma. That is in one eye, in the one visual field of one eye, there can be no perception at all. That is the person cannot see that part of the visual field. So the color vision next is with the Ishihara's chart. Then the fundoscopic examination is done with an ophthalmoscope. I have not included in detail here. I'm just mentioning it should be done with the ophthalmoscope. So next, coming to the pupil, in the pupillary light reflex, the afferent portion of the pupillary light reflex runs through the optic nerve. From there, the efferent component travels along the oculomotor nerve. So this examination basically involves two nerves. So it can be placed under either the second cranial nerve examination or in the third cranial nerve examination. So ask the patient to look at a distance and not into the light. So there also in the visual field, we read just now that the patient has to see straightly into the examiner's eyes. Here, we are not straightly seeing the light, but we are seeing at a distance and not into the light. The other eye is blocked off by the examiner. Then bring a bright light frame behind and observe the eye for ipsilateral pupillary constriction. Okay. So the pupillary size depends on the balance which is there between the parasympathetic nervous system, which causes the constriction, and the sympathetic nervous system, which causes the dilation via the sympathetic pathway originating in hypothalamus. So both optic and oculomotor nerve are working here, and both the sympathetic and the parasympathetic nervous system are also working here. So pupillary size is first observed and measured in dim light. Small pupils are termed myotic, large pupils are termed as mydriatic, and unequal pupils are termed as anisochoric. So please remember these names. First one is myotic, that is small pupils. Then large pupils are termed as mydriatic, and unequal pupils are termed as anisochoric. The pupillary light response is next tested. Okay, sorry, I have to say you the order. First one is pupillary size. We are measuring the pupillary size first. Then we are measuring the pupillary light reflex. So in the pupillary light response, this reflects a bright light is shown on each eye individually, and the pupils are examined for direct and consensual pupillary constriction. That is, so the direct one, you can stop at the screen. Okay, ma'am. So the direct one, that is, we are actually closing one eye and we are focusing the light on the other eye, in which the hand is not closing the eye. So in that, the direct responses on which eye the light is focused, that has to give some response. That is direct response. And the consensual response is that the other pupil, like the pupil of the other eye, also has to react to this light. Because in humans, like to the same light focused, both eyes, both pupils will react. So that we have to take care of, that we have to examine properly. So to test this reflex, a bright light is shown on each eye individually, and the pupils are examined for direct and consensual pupillary constriction. The afferent information for this reflex is carried by the optic, and the efferent response is carried by the oculomotor nerve. In addition to constricting to light, pupils also constrict when shifting from far to near gaze, and this response is known as accommodation. The stimulus for this response originates in the optic pretectum. So I'll repeat, while checking the pupil, we have three components now. So first component is we are checking the pupil size, that we will do in the dark. Okay, then pupillary light response, that with the bright light, and then we are checking for the accommodation, that is shifting from far to the near gaze, that comes under the accommodation. So pupillary abnormalities, normally what can go wrong? I'll give some two examples. One is okay, Hutchinson pupil. There is some condition called as Hutchinson pupil, in which a dilated pupil that does not respond to direct or consensual light. This lesion is because of cranial nerve 3. Okay, there is some lesion in the cranial nerve 3 which makes this go wrong. So this example is Hutchinson pupil, where the dilated pupil that does not respond to direct or consensual light. And there is other one, which is, we come across this actually very commonly, Horner's syndrome, a small pupil with associated ipsilateral ptosis and decreased facial sweating. So this lesion is in the sympathetic nervous system. So here you can see the light reflex. You can also see the image down below. So in the first one, normal, both pupils constrict. And if at all there is a third nerve lesion, there is loss of consensual pupillary light reflex. Sorry. And in the cranial nerve 2 lesion, loss of direct pupillary light reflex. So I said there is direct light reflex and consensual light reflex. Consensual light reflex is to which eye you are focusing the light, that is direct. For that light focused, the other eye should also reply or react. That is called as consensual light response. So in this condition, normal is both pupils should constrict, but in cranial nerve 3rd lesion, loss of consensual pupillary light reflex, and in cranial nerve 2 lesion, there is loss of direct pupillary light reflex only. So when we are checking the pupillary light response, please make it a point to examine it carefully whether the direct eye is responding or the other eye is responding. Only then we can mark or localize the lesion. As I said in the first point, we have to localize the lesion. Where is the lesion was the question. So in order to localize the lesion, we have to be careful in seeing whether it is third cranial nerve which is not acting properly, or whether it is the second cranial nerve, because one is the afferent fibers, the other one is the efferent fibers. So today we'll be stopping at second cranial nerve. In the next session, I'll be continuing from the third cranial nerve. If you have any doubts, you can ask now.